There's two. I told you guys when we started this, there was two parts for the fundamental theorem. This is the second part. Okay, the first part is what we've been doing before, evaluation part. Okay, so anytime we had bounds where we needed to plug in numbers, that's the first part. The second part is this. Sometimes it's called part two. Sometimes it's called the second fundamental theorem. It's the same thing. So what we're going to do, using the evaluation part of the fundamental theorem of calculus we learned last week, and the week before that, I think we started it 2 weeks ago, we are going to develop the concept for the other parts of the fundamental theorem. Okay, we're going to determine how to take derivatives from a function that is defined as an integral and discuss what it means to define a function as an integral. Okay, once we do that, we can answer these things. You're going to see these things a lot on assignments, tests, quizzes, questions about increasing, decreasing, questions about concave up, concave down, inflection points, things like that. You're going to see that today. Now, today, what we see today is going to be FRQ questions. You won't see these questions that you see today. You won't see these on multiple choice. They're not multiple choice type questions. They are FRQ questions, very popular FRQ questions. Okay, so you can pretty much guarantee that you're going to see something like this on your test when we take it next week. Okay, something with the second where you have to apply the second part of the fundamental theorem. Okay, so, and I'm telling you right now, if I do it, which I'm almost like 99% sure I'm going to ask you questions about increasing, decreasing, concave up, concave down, inflection points, maximum minimums. That's not on here too, but max, min, things like that. Okay, you've seen those. We've had tests and quizzes with those before. Okay, so those shouldn't be. We should know how to find those things already. But we haven't done it with integrals yet. Okay. All right. So first example. Find the integral from 2 to x for g prime. Okay. So g prime is a derivative. So if I wanted to find the antiderivative of that guy, what would it be? What would the antiderivative be for g prime? Take a wild guess. What do you think? Yeah, just g, right? Just g of t. Yep. Okay. And now we have to evaluate it using the first part of the fundamental theorem, right? So we're going to plug in x and we're going to plug in 2. Okay. Now, that's as far as I can go because I don't know what 2 is. I don't know what g is. They don't tell me what g is, but that's as far as I can go there. Okay. So part of the fundamental theorem is plugging in things that aren't numbers. We can do that. You plug it in just like you do a normal number. Okay. So the second part, example number 2. Do that part. It's pretty much the same thing as you just did. So do that part and I'll show you what the difference is. Just do that part there. Don't worry about the dx in the front. Just do that part right there. And I will help you out with the rest. Okay. So this part is exactly what you just saw. The antiderivative is g of t from x to 2. So we plug in x first, subtract it, plug in 2 first, we subtract it. We just did that, right? Now the d dx, what is the d dx, d over dx? What does that tell us to do next? Find the derivative, right? Okay, so let's find the derivative. So we have the integral is g of x minus g of 2. Okay, so what's the derivative of g of x? G prime of x, right? We just did the antiderivative. If the antiderivative of g prime is g, then the derivative would be g prime, right? So g prime of x, good. What's the derivative of g of 2? What's the derivative of g of 2? Not g prime 2, no. I mean, it could be, but we could simplify it even further. You could write it like that. Yeah, you could definitely write it like that, but we have an answer. What would the answer be? Not 2g. What is g of 2? Like if I knew what g was, what would I do? What would I do here? If I knew what g was, if they said g of x equals blah, 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 what would I do? What does this mean to do? Hmm? Yeah, y0. Yeah, y0, you rush. Yeah, what? So if I had g, I would plug in 2, right? I'd plug in 2 and I get some number, right? We've done it before. So really, this is a value. Plug in 2, get a number, right? If that's an input, you would get an output. Well, the derivative of any output is always going to be 0 because the output is going to be a number. It's going to be a value. So that means the entire thing equals g prime. Okay? So I want you to look from beginning to end. From beginning to end. What did we do? Instead of having to do all that work, what is the shortcut? What is the shortcut for this guy to go from yellow to green? To go from yellow to green, what is the shortcut? I mean, you could do all of these steps, but I mean, I think there's a way we can take away those steps. Yeah, Sebastian? Yeah, so the antiderivative and the derivative kind of cancel each other out, right? So that's essentially what these guys are doing, right? The derivative and the antiderivative. So we don't really need these, right? So how could I go from the yellow to the green? What could I do? What's a quicker way of doing that? Mhm. Keep going. Yeah, that's exactly what we did. Yeah. But even easier than that, isn't this all I'm doing? Taking this guy and putting it right here. That's my answer. That's essentially what the second fundamental theorem says. It says when you have a variable up there, you just put it there and that's your answer. Okay? That's essentially what it is. Now we're going to go a little bit deeper than that, but that's essentially what it says, what the second fundamental. So the second fundamental theorem is pretty simple. It's a pretty simple concept to take in. Okay? When we have a situation like this, when we have a variable on top, now it has to be on top, can't be on bottom. You just put it in there and you're done. Okay, so this whole thing here, we could have just said, okay, instead of g prime of t, it's going to be g prime of x. Okay. Okay, so let's look at something like this. All right, so if G equals so G is the same thing. I'm going to color code this so it may be a little easier to see. So G is the same thing as this. Then what is G prime? There you go. Yeah, it's asking the same question as number 2, right? It's just worded differently. There's no ddx, right? But it's essentially asking the same question. If you're finding the derivative of this guy, and this guy happens to be an antiderivative, don't the derivative and the antiderivative cancel each other out? So essentially all we're doing is moving this guy here, and you have f of x. Okay, now if you didn't understand that, you could do it. We could do it. Like, I'll do it right now, because just to show you. So if we want to find G prime, right? So first thing I have to do, so essentially what I'm doing here, so G prime is going to be the derivative of this guy here. Oops. Right? It's just the derivative. So I find the antiderivative of f. The antiderivative of f is just capital F. So capital F of t, and then I evaluate it from f of x to -2. Okay, so capital F of x minus capital F of -2. That's the antiderivative. And then I have to take the derivative of that. So I have to take the derivative now of capital F of x minus capital F of -2. The derivative of the antiderivative, what's the derivative of the antiderivative? The original. And then this guy here, again, it's just a value. So it's going to be 0. So again, either way, I don't care which way you do it. It doesn't matter to me which way you do it. You could do it the long way, the way we've done it before, right? You'll get the same answer as that. But that's essentially what the second fundamental theorem says. If you're taking a derivative of an integral, you just go back to where you started. Different letter. Okay? All right, so do number 4. Either way, I don't care which way you do it. Do it the short way, do it the longer way. I care more about getting the right answer. So if it's going to take you the longer way, take another 2 minutes and do it that way. But if you understand kind of what the shorter way is, do it that way. Okay? I'll give you 3 or 4 minutes to do it. Okay? Okay, so the short way is take this variable, replace it, and no replacement there. So the short way would be 5x to the third power minus 4x plus 1. If you're not sure of that, the longer way is find the antiderivative of this guy first. So let's find the antiderivative of this guy first. So the antiderivative would be 5t to the fourth divided by 4 minus 4t squared divided by 2 plus 1t, or just t. And we would have to evaluate it from x to 3. Okay. So that means we have 5/4 t to the fourth minus 2t squared plus regular t from x to 3, right? So we plug in x first, plug in 3, see what we get. So if I plug in x, I just get 5/4 x to the fourth minus 2x squared plus x. This part we've done before many, many, many times. And then if I plug in 3, I'm going to get 5/4 times 3 to the fourth minus 2, 3 squared plus 3. All right. So 3 to the fourth is, I think, what is it, 64? So 5/4 times 64 minus 2 times 9 plus 3. Let's see, the 4s would cancel out. You get 16. So you get 5/4 x to the fourth minus 2x squared plus x. 16 times 5, 0, carry the 3, 80, minus 18 plus 3. 80 minus 18 is 62, plus 3 is 65. Minus 65. Now what do I have to do with this guy? Now what's the last step for this guy? Find the derivative. So move the 4 to the front, you get 5x cubed. Move the 2 to the front, you get 4x. Plus 1, that guy drops. That's your answer. And it's the same answer that we started with, right? But one's the longer way, one's the shorter way. You know how to do the longer way. It's not like you don't know how to do the longer way. So if the longer way makes more sense to you, do the longer way. It took me 3 minutes to do it. What's better? Struggling for 20 minutes or spending 3 minutes doing the longer way, getting the right answer, right? If you see something like this and you're stuck, right? Mathematics says we do what's on the inside. So you're going to do this first. You know how to do that. Antiderivative, fundamental theorem. And then once you're done, take the regular derivative, okay? Or if you know it, you're like, oh, second fundamental theorem. Boom. Okay? Either way, I don't care which way. Okay? Okay, so now here is more likely what you're going to see on a free response question using the second fundamental theorem. Okay? Now that we have established how to derive an integral function, that's what we've been doing. Let's look more closely at what it means to define a function as an integral. Okay? So, g of x is the same thing as this guy here. Okay? So this guy looks familiar. Where the graph of w of t is given below. Okay, so w of t is given below. That's important to know. This is w of t. It's not g of x, it's w of t. Okay? They want us to find g of 0. G of 0. Doesn't that mean I just plug in 0 for g? Okay, let me do that. That's it. So let me plug in 0 for g. Where else do I plug in 0? Where else do I plug in 0? Where else do I plug in 0? Can't make it any bigger. There you go. I see another x, right? Anywhere there's an x, I plug in 0. There's another x right there, right? I can plug in 0 there. Okay, so let me do that. -2, 0. I don't plug in 0 for t because it's only plugged in for x. How do I solve this? How do I solve that? We've done it before. How do I solve this guy here? Because that's essentially what I'm doing. That'll give me my answer. How do I solve that guy? That's exactly right, right? I have this. Where is this at? W of t. Where do I know where is W of t? There it is. Doesn't this mean area under the curve? For this guy here? From where to where? From -2 to +1. Or sorry, 0. Sorry, from -2 to 0. Okay, so let's go from -2 to 0. -2 is right here. 0 is right here. So from -2 to 0, we're going to shade back towards the x-axis. We've done this before. You guys had it on your quiz that we took a few weeks ago. So essentially what that question is asking is how much area is in that curve, under those curve from -2 to 0. All right, well, this is a triangle. This triangle here has got a height of 1 unit. It's got a base of 1 unit. Area of a triangle is base times height divided by 2. So if I multiply and divide by 2, I get 0.5. This guy right here is the same thing. So what's my answer going to be? What's the area, total area under the curve? I see. I knew I was going to give 2 answers. 2 answers, 1 or 0. There you go. Yeah. One of them's under, so it's going to be negative. One of them's over, so it's going to be positive. So you're going to get 0 as an answer. Be careful with that. Yeah. Be careful with that. If it's under, it's negative. If it's over, it's positive, right? Okay. Okay. So now I want you to do B and C. I'll give you about 5 minutes to do B and C. Okay. So the area from -2 to +2. -2 to +2. So we still have that same area we had earlier. That was negative. That's going to be -0.5. So we have -0.5. And then we have this bigger area here that's positive, right? Kind of a trapezoid triangle looking thing here. It's up to you how you do it. It doesn't really matter. I mean, the easiest way is probably to break it up into smaller pieces. So 2 triangles in a rectangle. So the rectangle, you're going to get, what is that, +2, +2? And then the triangles, you're going to get, this is 0.5 because it's the same triangle we had last time. The top triangle, the base is 2. The height is 1. 2 times 1 is 1 divided by 2. You get 1. So we get, what is that? 1 plus 2 plus 0.5 minus 0.5. So the 0.5s will cancel out, and you get 3. Okay. This guy here, I was waiting for some people to say we can't do it. Why can't we do this problem? Yeah, it's not that we can't do it, it's that we can't do it the way it is. The bounds are off, right? The top number is smaller than the bottom number, and that needs to be flipped. We can do that, we just have to flip it. So we have to put them negative in front, and we can switch the bounds. Now we can do it. So whatever answer you get, change the sign. So if you got a positive answer, it's going to be negative. If you got a negative answer, it's going to be positive. Okay? So this guy here is from -3 to -2. So -3 to -2. That's a trapezoid. So base 1 is, what is that? 2. Base 2 is 1. 2 plus 1 divided by 2 times the height, which is 1. And we get 3 over 2 times 1, which is 3 over 2. Now, normally that's going to be a -3 over 2 because it's under the curve, right? But because of this guy over here, it's actually going to be a positive 3 over 2. It's actually going to be a positive 3 over 2 because of that guy there. Okay, because anytime you switch the bounds, the sign switches. Okay. Okay. Now, last thing we're going to do today, fill out this table. We've actually done some of these before. We've already done some of these before. It's a new function though, right? It's a new function. New graph. The graph represents f of t. So essentially we're doing the same thing. We're finding g of -3, g of -2, g of 0, g of 1, g of 2, g of 3. We're doing the same thing. We're just doing it in a table now. Okay? So I'll let you guys do the table in a second here, but I'll get you started. Let's try g of -3 first. Let me try g of -3. So g of -3 equals, up here it says -1's on the bottom, so -3 is on top, f of t dt. Okay, so that's, we have to find the area from -1 to -3. But again, the bounds are off. The top has to be the top, has to be higher than the bottom. So we have to flip the bounds. Okay, so it's going to be -1, -3, f of t. That's what we're trying to find. Okay. So -1 to negative, wait. What did I do right? Yeah, -3 to -1, sorry. So -3 to -1. Oops, let me use a different color. Two triangles. The triangles appear to be the same size, but let me verify to make sure. One of them has a height of 2 and a base of 1. So 2 times 1 divided by 2 is 1. Same thing here, right? So these are going to be the same size triangles. One's above the x-axis, one's below, so they're going to cancel each other out. So actually, the area is going to be 0. Okay? So what I want you to do now, I want you to spend 10 minutes. We are less than 10 minutes, 8 minutes. Fill out the rest of the box. Fill out the rest of the box. What do you get? Using g of x